Part C. That was one question for this part, one problem. Optical Society of America bonus question. Researchers have developed a lens made of liquid. The spherical lens consists of a droplet of transparent liquid resting on an electrically controllable surface. When the voltage of the surface is changed, the droplet itself changes shape. It either tries to ball up more strongly or it becomes flatter. The figure below is a sketch of the liquid lens and several parameters that describe it, including the thickness of the lens T, the radius of curvature of the top surface R, and the contact angle theta, which represents the angle between the flat surface beneath the droplet and the tangent to the curved surface at the point of contact. There are 6 questions for this part. Question A. When a certain voltage is applied, both the contact angle and the lens thickness increase and the lens become more curved. In this case, is the liquid attracted or repelled by the surface? Question B. Express the contact angle as a function of radius r and thickness T. C. The total volume of the liquid lens is an important parameter because as the liquid lens changes shape, its volume is conserved. Calculate the volume of the lens as a function of the radius and the thickness T. D. Use your result to part B to eliminate the variable T from your expression for the volume and find the volume as a function of radius and theta. E. By changing the voltage on the control surface, the contact angle theta can be changed, which in turn changes the focal length of the lens. F. The lens maker's formula can be used to calculate the focal length and is given by formula 1 over F equal N liquid minus N air multiplied by 1 over R1 minus 1 over R2, where N liquid and N air are the refractive indices of the liquid in the lens and the air around it, and the R1 and R2 are the radii of curvature of the two surfaces of the lenses. In figure, R1 is the curved face and R2 is the flat face. Use the lens maker's formula to calculate the focal length of the lens in terms of the total volume of the liquid, the contact angle, and the relevant refractive indices. Side note: liquid lenses are interesting because they are electrically controllable, variable focus lenses that can be very compact. People are working on putting them into cell phones, cameras for ultra-compact zoom lenses. Question A. When a certain voltage is applied, both the contact angle and the lens thickness increase, and the lens becomes more curved. In this case, is the liquid attracted or repelled by the surface? Answer. When curve is increased and angle increased, this droplet will go up It means that it's going against gravity. It means that voltage will repel this droplet. That's the answer. B. Express the contact angle as a function of radius r and the thickness t. Answer. From geometry we see that this angle theta equal this angle theta because of perpendicular sides for both. And from geometry we see that this side equal r minus t, and this will be catered, and this is hypotenuse r. So it means that cosine theta will be this expression r minus t over r, or 1 minus t over r. That's the answer for part B. Question C. The total volume of the liquid lens is an important parameter, because as the liquid lens changes shape, its volume is conserved. Calculate the volume of the lens as a function of r and t. To calculate volume, we have to put this picture on our xy graph. Suppose that y starts in the center of this circle, and y direction is straight up. So it means that top will be when y equal r. And we have to integrate our cross-section, area of cross-section by y direction. So on a distance y from the center of this sphere, we have expression for radius. Radius of this circle equal r square minus y square. So it means that we can count what is area by multiplying this radius by pi. And finally we have this result. Volume equal integral from pi r square dy, and limits are from r minus t to r. You can see it from this picture. So instead of small r square, we can insert r square minus y square, and we have this integral. And now result will be pi r square y minus 1/3 y cube, and the limits are from r to r minus t. When we insert these limits, we have this one, and after calculation, this is the final result for volume. This is how to express volume using radius and thickness of this lens. Next question, D. Use your result to part B, variable t, from your expression for the volume, and find volume as a function of radius and theta. In part B, we already found that cosine theta equal 1 minus t over r. From this formula, we can find that t could be expressed through radius and theta this way. Thickness t equal r multiplied by 1 minus cosine theta. And now we can substantiate this t to formula for volume through radius and t. That will be this expression. And now we can combine these results and finally get this expression. Volume equal 1/3 pi r cube multiplied by 2 minus cosine theta and multiplied by 1 minus cosine theta square. That's the answer for question D. Question E. By changing the voltage on the control surface, the contact angle theta can be changed which in turn changes the focal length of the lens f. The lens maker's formula can be used to calculate the focal length and is given by formula 1 over f equal n liquid minus n air multiplied by 1 over r1 minus 1 over r2, where n liquid and n air are the refractive indices of the liquid in the lens and the air around it, and r1 and r2 are the radii of curvature of the two surfaces of the lens. In figure, r1 is a curved face, which is r, and r2 is the flat face, where r2 equal infinity. Use the lens maker's formula to calculate the focal length of the lens in terms of the total volume of the liquid, the contact angle, and the relevant surface indices. Answer. This formula, lens maker's formula, we can rewrite in form of this one, because r2 equal infinity and 1 over r2 equals 0. So this is the expression for focal distance for a lens. And now we can express our radius through volume. For that we use this formula. Volume equal 1/3 pi r cube multiplied by this expression. And we can represent r through volume. That will be this numerator if we do proper calculations. And final answer will be like this. That's the answer for question E.